Hi, I'm Benny D, and in this video we're going to be looking at determining the rule for a function from its graph. Okay, so things that we need to be all over to sort of answer these questions are general forms of a few equations or functions. So for example, we could have a hyperbola, okay, in the form of y equals a on x take h plus k. It could be a truncus, so it's going to be squared. Could have a power function, okay, a outside of x take h to the power n plus k. You'll know what the n is though. Okay, it won't be something you need to determine. Okay, or it could be something like a square root function. Okay, any of these type of functions. Okay, usually you'll be given one. Okay, and the other thing that you'll need to do is you'll be trying to find these values of a, h, and k. And so you'll be given other information that you can use along with information that you know about different types of functions to help you as well. So let's have a look at a worked example. So in this worked example, we know that the points 1, 5 and 4, 2 lie on a curve with an equation of y equals a on x plus b. And we're required to find the values of a and b. So in order to do this, there's not much about a hyperbola that helps us out. Like there's no nice point. It's just this sort of shape. It's not like a nice quadratic or something like that where we know we've got a turning point that we can utilize our knowledge about. So we can't use that to help us. So what we need to do is actually sub in both of these points into this function to create two equations that we can solve simultaneously to find a and b. So I'll set our first one up. We know that 5 has to equal a over 1 plus b. So simply 5 equals a plus b. It's going to be equation 1. Equation 2, we're going to have 2 equals a over 4 plus b. Okay, that's our equation 2. Now, as per my previous videos, most of the time substitution is going to be the more efficient method for solving these, but you could shoot for elimination if you wanted to. I'm going to stick with substitution here. So we need to rearrange one of these equations for either a or b. I'm going to go with equation 1, and I'm going to rearrange it for a, but it won't really matter which way you went. So I'm going to say then that a equals 5 minus b. Okay, so that was my equation 1. And now I'm going to start over here. I'm going to go equation 1 getting subbed into equation 2. So everywhere I've gone A, I'm going to put 5 take B. So I'm going to have 2 equals 5 minus B over 4 plus B. And I'm going to times everything by 4. So I'm going to get 8 equals 5 minus B plus 4B. So I'm going to take my 5 away to leave me with 3. Minus B plus 4B is going to give me 3B. Divide by my 3, I'm going to get b equals 1. Okay, and I can sub my value for b back into equation 1 that's rearranged because that one's already been rearranged for a. So then we get a equals 5 minus 1, which is 4. Okay, so our values for a and b are a is 4 and b is 1. Okay, we'll have a look at another worked example as well. So this time we know that the point 2, 1, okay, and 10, 6, okay, lie on a curve with an equation of y equals a times the square root of x take 1 a plus b. So this time we've got a square root function. Okay, we know it's been translated to the right by 1 unit. Okay, so we don't have to find the value of h. Okay, so again, we've got two points that we know it goes through. Okay, we can use those, set up two equations, solve it simultaneously for a and b. Okay, a square root function, of course, has that nice interesting point that usually is at the origin. Okay, neither of these points are going to work very well for tracking that. If, for example, this point was the point, say, 1, 2, then we'd instantly know what the value of b is because we know it's been translated to the right by 1 unit. So a point 1, 2 would actually be tracking this endpoint, okay, the coordinate of which, okay, the y value of the coordinate of which is b. Okay, so we would be able to do something like that with a square root function at times, okay, but we'll go with our same process as last time of setting up in our two equations. So we can say 1 equals the square root of x take 2, x is 2, 2 take 1, a plus b, can't forget that a at the front. Okay, so we get 1 equals, well, 2 minus 1 is 1, square root of 1 is just 1, so you get a plus b equaling 1. We'll call that equation 1. Now equation 2, we're going to use this information, so we're going to say, well, 6 equals a times the square root of 10 minus 1 plus b. Okay, well, we know 10 minus 1 is 9, square root of 9 is 3, so we're going to say 3a plus b here for equation 2. Okay, so again, we want to look and go, okay, what is going to be the best thing to rearrange here? Well, it's probably equation 1 again. Let's go for a, and say that a is 1 minus b, so that's our equation 1. Just like last time, we're going to substitute equation 1 into equation 2. Okay, so anywhere I've got a in equation 2, I'm going to put 1 minus b. So we get 6 equals 3 times 1 minus b, a plus b. We're going to expand our brackets out, so we get 3 minus 3b plus b. Okay, collect some like terms here. So minus 3b plus b is going to give us minus 2b. We're going to take away our 3 here. Because 3 equals minus 2b. So b is going to equal negative 3 on 2. Okay, and then we're going to substitute this value into my rearranged equation 1 because a is already the subject of the equation. A equals 1 minus negative 3 on 2, so we're going to add it on. Okay, so a is going to equal 5 on 2. Okay, because we simply think of 1 as 2 on 2 plus 3 on 2 gives us 5 on 2. So there we have our value of a and our value of b. Okay, so it's very much an application of simultaneous equations for the most part with these type of questions, but you may need to utilize your knowledge of particular functions and their shape to help you along and make things a little bit more efficient.